Ask My Instructor 2.6.33. Use the continuity checklist to show that f of x is not continuous at 2. Is f continuous from the left or from the right at 2? State the intervals of continuity. Part 1. Use the continuity checklist to show that f of x is not continuous at 2. The function f is continuous at x equals 2 if the point is in the domain, the limit exists, and the function evaluation at 2 is the same as the limit at 2. So first we ask ourselves, is the point x equal 2, is that in the domain of f? Well, it is. You can see if you look at the function that if x is equal to 2, then the function is guided by the top expression. And so when x equals 2, f is going to be 2 squared plus 2 times 2, or 8. So yes, the point x equals 2 is in the domain of the function. And so now we look at the second requirement. We need to see if the limit as x approaches 2, we need to see if that limit exists. If x is bigger than 2, then f of x values are calculated by x squared plus 2x. So, the limit as x approaches 2 from the right, that limit is guided by x squared plus 2x. And so coming from the right, the limit is equal to 8. On the other hand, if x is less than 2, then f of x values are calculated by the bottom expression 3x. So the limit as x approaches 2 from the left is equal to 6. The limit as x approaches 2 from the right is 8, and the limit as x approaches 2 from the left is 6. In order for the limit to exist, we must have the left and right hand limits agree. Since they don't agree, the limit does not exist. So, the second criteria is not fulfilled, and f of x is not continuous at x equals 2. We do not need to look at the third criteria because we've already shown that it fails the second. Part 2. Is f of x continuous from the left at 2? Is f continuous from the right at 2? The function is continuous from the left at 2 if the limit as x approaches 2 from the left is equal to f of 2. And the function is continuous from the right at x equals 2 if the limit coming from the right is the same as the function evaluated at 2. We already discovered from part 1 that the limit as x approaches 2 from the right is 8, and that the limit as x approaches 2 from the left is 6. We also have already found out that f of 2 equals 8. Since the limit as we approach 2 from the left is not the value of the function at 2, the function is not continuous from the left. Since the limit as x approaches 2 from the right is the same as the value of the function at 2, the function is continuous from the right. Part 3. State the intervals of continuity. For x equals 2, the function is a polynomial which is continuous. So f is continuous on 2 to infinity. In addition, we have learned from part 2 that f is continuous from the right at 2. So f is continuous on the interval 2 to infinity, including 2. That straight up and down bracket means I include the value 2. For x being less than 2, the function is a polynomial which is continuous. So f is continuous from negative infinity to 2. However, we learned from part 2 that f is not continuous from the left at 2. So f is continuous on negative infinity to 2, not including the end point 2. And if we look at a graph, it's fairly easy to see that we have continuity, negative infinity to 2, not including 2, and then again from 2 to infinity, but this time including 2. All right, I think that finishes the problem. We're all done. Have a good day, and let me know if you have any questions. Take care.